The third question says, verify whether the following are zeros of the polynomial indicated against them. So let's take the first part. P of x is equal to 3x plus 1, and we have to check whether x is equal to minus 1 by 3 is a zero of this polynomial. So I'm going to write this here. So P of x is 3x plus 1, which means that P of minus 1 by 3 is equal to 3 into minus 1 by 3 plus 1. So I'm just substituting minus 1 by 3 into 3x plus 1. So that's 3 into minus 1 by 3 is minus 1. So minus 1 plus 1 is equal to 0. So minus 1 by 3 is a zero of Px in this case. Now let's go to the second part. So in the second part, the polynomial is P of x is 5x minus pi, which means that P of 4 by 5, which is what we have to calculate, 4 by 5 here. So this will be equal to 5 times 4 by 5. So I'm again substituting 4 by 5 in the place of x minus pi. So 5 and 5 cancel, and I have 4. So 4 minus pi, which is non-zero. So in the second part, 4 by 5 is not a zero of the given polynomial. Now let's go to the third part. So in the third part, the polynomial is Px equal to x square minus 1. And I have to find out whether 1 and minus 1 are zeros of this polynomial or not. So one way is to substitute. So I have P of 1 is 1 square minus 1, that is 0. And P of minus 1 is minus 1 square, which is again 1 square. So that's 1, and 1 minus 1. So P of minus 1 is also 0. So both 1 and minus 1 are zeros of this polynomial. You could also have verified this by factorizing x square minus 1. So if you do that, the factorization of x square minus 1 is x minus 1 times x plus 1. So from this factored form, you can immediately see that both 1 and minus 1 are zeros of this polynomial. So in option 3, both the values are zeros of the given polynomial. Now let's go to part 4. So in the fourth part, the polynomial is Px equal to x plus 1, x minus 2. So this is the fourth part. And I have to verify whether minus 1 and 2 are zeros of this polynomial or not. But if you look at the linear factors of this quadratic polynomial, x plus 1 and x minus 2, you can immediately see that x equal to minus 1 is a zero of this linear polynomial and hence of Px. Similarly, x equal to 2 is a zero of this linear polynomial and hence it is also a zero of Px. So both minus 1 as well as 2 are zeros of Px, which means that you don't really need to expand this product and then substitute the value of x. You can directly observe the linear factors and determine that minus 1 and 2 are both zeros of Px. So that's part 4. Now let's go to part 5, which is Px equal to x square, and the value given to us is x equal to 0. So it's obvious just by observation that x equal to 0 is a zero of Px. So that's part 5. Now let's go to part 6. In part 6, we have Px equal to Lx plus m. So Px equal to Lx plus m, and this is a linear polynomial. And we have to find whether x equal to minus m by L is a zero of this or not. So this means that P of minus m by L will be equal to L times minus m by L plus m. So the L and L cancel, and I have left with minus m as the first term and m as the second term. So this is equal to 0. So P of minus m by L is equal to 0. So minus m by L is a zero of the polynomial in this case. And you could also have observed this simply by equating this to 0, Lx plus m equal to 0. And if you do that, you will get x as minus m by L, which means that x equal to minus m by L is the zero of this linear polynomial. Now let's go to part 7. So in part 7, the polynomial is, so this is part 7, and the polynomial Px is 3x square minus 1. and the values given that we have to verify are x equal to minus 1 by root 3 and x equal to 2 by root 3. So one way is to equate px to 0, because finding the zeros in this case is fairly simple. So if I do that, if I equate px to 0, this gives me 3x square minus 1 is equal to 0, or x square is equal to 1 by 3, or x is equal to minus 1 by root 3 and plus minus 1 by root 3. So these are the two zeros of px, which means that minus 1 by root 3 and 2 by root 3, both of them are not the zeros of px. So minus 1 by root 3 is a 0, but 2 by root 3 is not a 0 of px. The other way to do this would have been to substitute both minus 1 by root 3 and 2 by root 3 into px, and then you will find that p of minus 1 by root 3 will be equal to 0, because minus 1 by root 3 is a 0 of px, but p of 2 by root 3 will actually be not equal to 0, and you can actually verify this. So in part 7, both the given values are not the zeros of the given polynomial. Finally, let's go to part 8. So that's px is equal to 2x plus 1, and the value given to us is x equal to half. So if I substitute x equal to half, I get p of half is 2 times half plus 1, that's 1 plus 1, that is equal to 2. So p of half is not 0. So x equal to half is not a 0 of px. In fact, the 0 of px is actually going to be minus half. So this question is done. Let's move on to the fourth question. To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.